Hello everyone. Welcome to the course of lecture Testing and Commissioning of Electrical Equipment. Here we are in lecture number 42 that is totally deals about duties and drying of synchronous machine and also for all rotating machines. The limits of temperature rise has the reference to the standard duty specified for the machine. That is thermal rotating classes of industrial rotating machine and standard symbols for operating duty is very essential for all the rotating machine. So according to IEC, IS and BS standards of specification, the standard duty classes are designated as S1, S2 up to S8 as described. The standard operating conditions are designated by the letter N, R, D, F, V, like that. The rotating classification based on operating has designated like MCR, ECR, DTR. Here, the temperature rise depends upon the operating duty for a particular machine and depends upon the local conditions of load and duty cycle. Precise operating duty varies with various operating conditions and the standard duty classes for the guidance for the manufacturer and also user. So some standard duty cycle for industrial rotating machine are described here. First one, it is S1, it is continuous operation at rated load, like it is denoted as continuous duty. Next is S2, short time operation or short time duty. S3, it is an intermittent periodic operation. S4, intermittent periodic operation with starting, and S5 is intermittent periodic duty with starting and electrical braking. Then after that, S6 denotes continuous cyclic operation, that is intermittent periodic loading, that is means cyclic operation. Okay. Next, after that S7, it is continuous duty with starting and electric braking. S8 denotes continuous duty with periodic speed changes, that is related load speed characteristics. The symbol for operating duty of industrial rotating machine as N, R, D, F, V, like that. So N is operation with normal rated load. Then R denotes machine at rest and de-energized. D is starting duty. F braking duty. V operation at no load but rotating. Cyclic duration factor. It is one of the important phenomena in rotating machine. It is defined as ratio of operating period to the total period of a cycle. So here, according to the duty of the rotating machine, we have the factor, that is cyclic duration factor, for each and every electrical rotating machine. So this table describes duty and accordingly the cyclic duration factor of the rotating machine. So it is from S3 to S6, and also for n divided by n plus r denote cyclic duration factor for S3 type of machine. Like that you have these descriptions here. So n is operating period in a cycle, r is rest period, d is starting period, f is braking period, and v is no load rotating period. Here these are the classes of duty we have seen, and in detail we will see with the characteristics of that particular machine and its example also. First one, S1 is continuous operation. Motor is running long enough and temperature reaches steady state value. For example, it is paper mill drive, conveyors, and compressor. These machines and drives operating for a long duration of time. So this is the characteristics of temperature and the continuous duty characteristics of that particular machine. Short time duty. In these motors, the time of operation is very low and the heating time is much lower than the cooling time. These motors are used in crane drives, drives for household appliances, valve drives, like that. Next one is intermittent periodic duty. It is S3. So each and every time we are loading here. See, this seen as press and drilling machine drives. So in some period of time, the drive running with load. Other period, it is not having any of the loads. Intermittent periodic duty with starting. In this type of duty, there is a period of starting which cannot be ignored and there is a heat loss at the time. This motor duty classes is widely used in metal cutting, drilling tool drives, mine hoist, like that. After that, the intermittent periodic duty with starting and breaking. What are this? Starting and breaking denotes the continuous cyclic operation, right? So in this type of drives, heat loss during starting and breaking cannot be ignored. These techniques are used in billet mill drive, manipulated drive, and mine hoist, etc. So continuous duty as well as periodic loading. In this, it continuously working for a particular 2 hours. Suppose the motor working at 2 hours means after 2 hours, the motor is loaded and it continuously working. In this time, motor duty, everything is same as periodic duty, but there has a no load running period is occurred instead of rest period. So without no load, without load, sorry, it is running continuously. So pressing, cutting, or example of this system. So continuous duty with starting and breaking. It consists of periodic cycle, each having a period of starting, a period of running at a constant load, and a period of breaking. So there is a no period of rest. So for example, blooming mill working as a continuous operation with starting and breaking cycle. So here we have the thing that speed changes. Periodic speed changes, that is depends upon load speed characteristics. It consists of periodic duty cycle, each having a period of running at one load and speed and another period of running at different load and speed. So there is no period of rest. For this example is paper mill dry. Next topic we are going to see is drying out of synchronous machine. The moisture absorbed by the insulation is to be removed by drying till insulation reactance reaches specified value. Here it is a resistance, okay, insulation resistance. We have the test also for measuring the insulation resistance. The moisture is evaporated from the winding due to thermal diffusion. Here the moisture gradient depends on temperature gradient within wet insulation. Desired temperature is obtained by heating the winding. The insulation resistance is measured by means of DC mega ohm meter, that is Megger. To measure insulation resistance of the winding up to 1000 volt, Megger of 500 volt, while 1000 volt Megger is used for machine winding rated up to 1000 and above. The face-to-face and face-to-earth insulation resistance IR at the working temperature of the machine should not be lower than the value found from the analysis. That is already derived for that particular machine. So here the insulation of the rotating machine is hygroscopic nature. So always the moisture absorbed by the insulation, it is to be dried out till the insulation resistance reaches its specified value. So here, this is one experiment for drying out the moisture exists in the machine. So here the machine stator winding are supplied with low voltage. See here it is a stator winding supplied with the low voltage, reduced voltage we are applying here. The input voltage, current, power, temperature of the winding, temperature of the body, temperature of the air are periodically measured. So we have the meter. So the winding temperature, then the temperature of the machine, current, voltage, power, everything is monitored. So the end shields of the machine are removed. The machine for ventilation purpose, right? The machine body is covered with a tarpaulin. No cool air blow come over the hot winding. So here, the preparation and precautions and logbook keeping during drying is must. The machine should be always attended when drying out is in progress. So here, you are applying low voltage for heating up the winding. So always temperature, power, current maintain within that specified limit, and also keep in mind the end shields of the machine are removed. So these are all the procedure for drying out of synchronous machine. For induction machine and transformer, we have the separate drying out process that we will see in the next class, drying out process. So in this class, we have seen the duty, various kinds of duty and operation and its examples also. And finally, we have completed drying out of synchronous machine. So that's all about the lecture 42. So in the next lecture, we will see testing procedures of synchronous machine. Thank you once again.